Let's dive right into this explainer. Today, we're going to explore the incredible, totally invisible chemistry that's happening all around us, and honestly, right inside of us. We're focusing on a group of chemicals that are absolutely essential to our survival, yet are also capable of profound destruction. We are talking about acids. I want you to think for a second about the harsh, incredibly powerful chemical reactor sitting inside your own body right at this very moment. Every single time you eat, a really complex biochemical breakdown kicks off. But how exactly does a solid piece of food turn into the microscopic fuel that powers your cells? Well, the secret lies in a highly corrosive environment right in your gut.
So, we're going to take a fascinating journey today. We'll start by zooming in on the microscopic world of our own digestion, then step out into our kitchens, and finally, look at the macroscopic impact of these chemicals on the wider global environment. Section 1. The acid in your stomach, biological reactor. As you'll see, your own stomach actually relies on hydrochloric acid to function and extract all those vital nutrients from your meals. This is a remarkably strong mineral acid. Without it, human digestion would literally grind to a halt. It's just wild to think that our biological tissue is specifically designed to safely contain a chemical that would otherwise severely burn our skin on contact.
Now, what's really interesting about this is that despite being potentially dangerous, acids all share some common observable traits. For instance, aqueous solutions of acids act as electrolytes, meaning they conduct electrical currents. They also react with active metals to produce hydrogen gas. And, perhaps most relevant to our daily diet, they have a distinctly sour taste. Think about the sharp bite of a lemon. That right there is the physical sensation of an acid on your tongue.
Section 2. Organic acids and digestion, fueling the body.
Let's move into our kitchens for a moment. This chart brilliantly illustrates how the weaker, organic, carbon-based acids found in our everyday foods actually support our internal systems. Look at lactic acid, which you find in yogurt. It actively promotes gut health by supporting beneficial bacteria. Or malic acid in apples, which aids in energy production. When we consume these everyday items, we're basically sending in chemical reinforcements to keep our digestive cycles running smoothly.
And you know, as a fun little bonus, these organic acids are incredibly versatile outside of our bodies, too. Take acetic acid, for example, which is the main component in household vinegar. If your morning coffee maker is brewing way too slowly, it's probably clogged up with lime deposits. Just run some dilute acetic acid, vinegar, through the machine, and it completely dissolves those stubborn deposits. Just make sure to run fresh water through it afterwards, unless you want a genuinely horrible tasting cup of coffee. Section 3. Neutralization and heartburn relief. Balancing pH. But what happens when we have too much of a good thing? Like when excess stomach acid causes that awful, painful burn of indigestion. That brings us to this absolutely crucial, yet surprisingly simple chemical equation of neutralization. When an acid and a base are combined in equal moles, they react to produce a harmless salt compound and water. In the context of our digestion, a basic substance steps in like a hero to neutralize the acidic villain that's causing our heartburn. We actually use this exact chemical reaction all the time in everyday life. When you get indigestion from too much stomach acid, you take an antacid, like milk of magnesia. That's a base, and it balances out your stomach's pH. But it definitely doesn't stop with digestion. We brush our teeth with mildly basic toothpaste to neutralize the acids produced by mouth bacteria, which stops tooth decay. If you get stung by a bee, which injects an acidic venom, rubbing on a base like baking soda instantly neutralizes the pain. Interestingly, a wasp sting is basic, so for that you'd actually use an acid like vinegar to neutralize it. Farmers even use lime, which is a base, to prep overly acidic soil for planting.
Section 4. Identifying acids safely. Natural indicators.
Now, stepping into a laboratory setting, we obviously can't go around tasting chemicals to see if they're sour. That is a terrible idea. So we need ways to safely identify these chemicals, which brings us to natural indicators. These are fascinating because they visually change color to warn us if a substance is an acid or a base. For instance, an extract from the red flowers of the China rose plant turns a dark magenta when exposed to acid, but it turns bright green when it hits a base. Turmeric, that common kitchen spice you might have in your pantry right now, turns brownish red in basic environments but stays totally yellow in acid. And litmus, a natural dye from lichens, turns red in acid and blue in basic solutions. Identifying acids safely is one thing, but actually handling them is another beast entirely. When we're dealing with concentrated acids in a lab, we have to treat them with immense respect.
Unlike the dilute acids fueling our digestion or flavoring our food, concentrated lab acids are strongly corrosive to all body tissue, especially the eyes and skin. Because of this, there is a very strict step-by-step procedure required for handling concentrated acids safely to prevent chemical burns or toxic inhalation. First up, personal protective equipment is non-negotiable: chemical splash goggles, an apron, and acid-resistant nitrile rubber gloves. You absolutely must work inside an operating fume hood because chemicals like concentrated hydrochloric acid are highly toxic to inhale. And here is a literal golden rule of chemistry: always add acid to water when diluting, never ever the other way around. Finally, falling back on our knowledge of neutralization, you should always keep a strong base like sodium carbonate nearby to quickly neutralize any unexpected, dangerous spills. But, accidents do happen. And if they do, remember that the absolute best first aid for almost any chemical exposure to tissue is immediate and continuous dilution. You need to get to a safety shower or eye wash station and flush the affected area with water for 15 to 20 minutes straight. Modesty literally has to take a backseat here to prevent severe chemical burns. Any contaminated clothing has to be immediately removed while rinsing.
Section 5. Acid in the environment. Global challenges.
For our final perspective, let's zoom all the way out to the Earth's atmosphere and look at the macroscopic impact of human pollution. When we burn massive mountains of coal and oil to generate electricity and fuel our millions of cars, we accidentally create a highly destructive environmental phenomenon known as acid rain. The sky drops what looks like totally normal water, but hidden inside those clear raindrops is a messy, corrosive chemical soup caused entirely by our pollution. It eats away at historical monuments, harms wildlife, and just wreaks havoc on local plant life. To combat this enormous scale of environmental damage, we once again rely on the magic of neutralization. Just as we use antacids to treat indigestion and settle our stomachs, environmental scientists dump immense quantities of limestone, which is a basic substance, into lakes and agricultural soils to try and neutralize the widespread lingering effects of acid rain. We are quite literally trying to give the Earth a giant antacid.
So, what does this all mean? It leaves us with this final, really provocative thought. Acids are an absolute necessity for life. From the hydrochloric acid carefully contained in our stomachs to digest our food, to the organic acids that fuel our cellular metabolism, we simply cannot survive without them. Yet, how is it that the exact same chemical properties that sustain human life cause such monumental global headaches when we recklessly let them loose into the sky? It's a delicate, incredible chemical balance, one that we rely on every single day, inside and out. Thank you so much for joining me on this explainer, and remember to keep questioning the incredible science happening all around you.